Okay, it's important to understand how a magnetic disk drive works so we can understand its performance characteristics. So a magnetic disk drive is a mechanical object made up of a bunch of platters and a bunch of heads. The platters sit on a spindle that spins them all together at the same time at, let's say, about 15,000 rotations per minute. That's pretty typical these days. And there's this arm assembly, and you can see a picture down below and a sort of schematic of it up right. The arm assembly moves in and out to position these reading-writing heads on top of a desired track of the disk. So logically speaking, looking at the schematic on the upper right, you can think of fixing a location for the disk head and then letting the thing spin. And it's as if there's a track underneath the disk head. Now, of course, if you look at the actual surface of a magnetic disk, there are no tracks. So this is just a logical notion. Similar logical notion, if you think of all of the heads stacked up with a single location, that defines a track on every platter. And those tracks together make what you might think of as a cylinder. It's a volume in 3 dimensions, right? It's basically the tracks that are stacked up on top of each other. We call that a cylinder. Now, a given cylinder, so that's a picture of a cylinder. The disk head is at a location which is the disk cylinder there. And the arm assembly can be moved in or out to position the head on a desired track. So if we move the arm in, then we're on different tracks, and those tracks make up a smaller cylinder inside. When we move back out, we get to that big cylinder again. Now, it's the case in most of these that the electronics allow only one head to read or write at any one time. That's not terribly important, but it's something you might want to know. And what they write is a multiple of what's called the sector size. So if you remember your geometry, a sector is a pie-shaped piece of a circle. In terms of disk drives, a sector is the part of a track that intersects with one of these sectors. So in the schematic on the upper right, that thick black arc is a sector. And a sector is a fixed size, fixed amount of data. And the block or page size that we transfer to and from the disk is some multiple of the sector size that's configured by the operating system when we format the disk. To access a disk page, it takes a certain number of operations, each of which take a certain amount of time. And there's 3 components of the time of access to read a disk block off of a disk. There's the time to seek. So that seek time is the time involved in moving the arm assembly to a position where the disk head can read the desired track. And that can take 2 to 3 milliseconds on average. Okay? Rotational delay then is the time it takes for the appropriate sectors or the appropriate block to rotate under the head. On average, that's going to take a half rotation of the disk. So with 15,000 rotations per minute, that's somewhere between 0 and 4 milliseconds. And then there's the cost of actually getting the data for that block off of the magnetic medium and into the RAM. And that is actually pretty quick. So that's something like 1/4 of a millisecond per 64K page if we have 64K pages. And so when you look at these numbers, obviously the thing you want to optimize is the seek and rotational delays. We'd like to minimize those as much as possible because those are where our big expenses are.